So we'll move quickly on to the next presentation. Can we pass the ball, please, to Jussi Happala to present 5G drones?
So 5G drones. So as the name says, we are all about drones. So all of our use cases are drone related, and as you can see from here, we are 20 partners around Europe with expertise on telco vendors, telco operators, also UAV operators, UAV vendors, UTM operators, etc., and also research institutions. So in this project, we have actually all in all 12 different use case scenarios that we are investigating. So they're roughly categorized in 4 different use cases. So first being the UAV traffic management, also known as UTM, which is an essential feature in all drone-related operations. So it has 3 scenarios covering the command and control application, 3D mapping to support visualization and analysis software for UTM, and UAV logistics. So the second use case relates to public safety, and in there are 3 scenarios: monitoring a wildfire, disaster recovery, and police counter UAS operations. So use case 3 is focusing on situation awareness, and the scenario 1, which is infrastructure inspection, has actually 3 different sub-scenarios. And scenario 2 is UAV-based data collection, and scenario 3 is focusing on location in non-GPS or non-basic positioning system-based environments. Lastly, the 4th use case is connectivity during crowded events. And in the project, we have 4 different sites. So we have the 5G Eve at Sophia Antipolis and 5 Genesis at Athens, representing our ICT-17 facilities. In addition to that, we have 2 other sites, which is the Oulu 5G TS test network and the Aalto-X network in Helsinki area. So as we said, there are 12 use case scenarios all in all. We have distributed them into different locations. This is also partially because of the various facilities have various physical areas that they are allowed to cover, and this kind of dictates what use case scenarios, especially when we are regarding drones that are fly and operate over significant areas, where they can be supported. So far, so we have on the left-hand side, we have the high-level architecture. So the project will build on top of the different facilities. So there is the trial controller and the use space to consider as well. So one of the main aspects from UAV and UTM point of view is to develop the use space adapter, which is essentially an interface to use space, and the use space is largely basically based on the CESAR joint undertaking efforts to cover unmanned space. It also uses learnings from Gulf of Finland use space project of which we have partners in. So the actual trial controller is the main endeavor as a common part of the project, and it covers web portal for experimenters, then the actual trial execution engine, and also then there is the abstraction layer to interface with the facilities. So the experimenter will access the web portal. So there are in fact 2 different web portals. So the first one taking care of that the trial that an experimenter desires is feasible in the first place from the use space point of view, from the area of operations point of view, etc. Whereas the web portal 2 then focuses on the capabilities of the particular facility covering that area. And without going into further details, I'll start telling that we did manage to conduct and are in the process of conducting various feasibility tests. So even due to the COVID situation, we have managed to conduct feasibility tests, which are kind of precursor to pre-trials and trials. So feasibility tests on the 5G TN and the Alto X network platforms. And 5 days from now, there will be feasibility tests on the 5Genesis Athens platform. The 5Genesis Athens platform has also conducted emulation tests previously in May. And okay, to briefly cap, the feasibility tests purpose was to see how the components between the UAV operators, the 5G facilities, and etc. can start taking place, to learn which things work, which need improvement, what are the key pitfalls in actual execution at trials, etc., etc. So this picture here is the use case that basically we had in Oulu, covering command and control and 5G quality of service. So as you can see, the drone operator is actually in Estonia, Tallinn. Basically, all of the drone operators software were in the University of Oulu edge server. And then, of course, on site there was the safety pilot. But as you can see, the main purpose of the safety pilot is just to hold the control, emergency control functions of the drone without actually touching the controls unless there is a situation. So the actual operations were conducted so from Estonia. We used 5G connectivity in non-standalone to connect with the drone and to carry out the quality of service. So with regards to feasibility test, I want to draw the attention. So in the figure in here, you can see 3 different user equipment from the 3 different operators. So each of them were doing speed test measurements, and you can see that the results are quite far from homogeneous. This is not a single, well, okay, this is a single instantiation, but it represents about the average of what we got from each of the devices over multiple trials. So the main message in here is that there are issues with the equipment stability on the market. So you can see that the downlink range was somewhere from 270 megabits to 400 megabits per second, and the upload was somewhere from 37 megabits per second to 20 megabits per second. And that is actually a thing that I want to emphasize, the uplink. So this kind of represents the 5G downlink uplink ratio that is at least used in Finland for the commercial operators. And this is a difficult feat for drone operations. So especially considering drones that have multiple different sensors and which require high bandwidth, for example, LiDAR, and 3D mapping. This uplink ratio is, or uplink capacity is not really sufficient for operations. So there's quite a lot of thinking, basically, what can be done to convince and enable in the future actual 5G operators to push up that uplink capacity on demand. Also, okay, there are many issues with maturity, homogeneity, and tractability of each of the devices and components in the network. But that's it from my part. So thank you for attention, and all of the documentation can be found from our deliverables.